It's triangle similarity. Well, that's the name of the unit, but this is proving triangle similar through one of the ways you can prove triangle similar. As you can see from this chart here, it's showing you the ways you can prove triangles to be similar. Like I said, some of y'all should recognize this, but you haven't learned this. You only learned the congruency, the ways you can prove triangles congruent. And if you don't remember the ways you can prove triangles congruent, I wrote them on the board for you. Side, 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 angle, side, angle, side, angle, 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 side, and HL. You can prove triangles congruent 5 different ways that you can prove triangles congruent. Only 3 ways you can prove triangles to be similar because of, the characteristics of being similar. You can prove triangles to be similar by angle, or that could be AAA, but we never write it as AAA because by the time you do angle, you've proven the triangles to be similar. Because if you know the thought process behind that is, if you know 2 angles of one triangle are congruent to 2 angles in another, then you automatically know the third angle in each of one of those triangles are congruent, because of what we know about triangles and what we know about the triangle angle sum theorem. So we only need to know that 2 angles in a triangle are congruent for the triangles to be similar. Now, if you remember, when we did congruency, the other unit, remember we said AAA was a way not to prove triangles congruent, which is true, because when you're trying to prove 2 triangles congruent exactly the same size and same shape, you can't prove those by angles, because the 2 triangles could have all the same angles in them, and one could be bigger than the other. We talked about that. So we can't prove congruency with AAA or AA, but we can prove similarity. If all the angles in both triangles are congruent, then that means the triangles are similar. They might not be the same size, so they may not be congruent, but they're similar. So just switching your thought process a little bit, because it kind of goes against what I told you in congruency, but it makes sense. Remember, in congruency, once again, we told you that angle was not a way to prove triangles congruent, but angle, or angle is a way to prove triangles to be similar. You can prove similarity in triangles with angle. And then you have the other one that side, side, side. That was for congruency too, but you could use side, side, side to prove similarity. But instead of the sides being congruent this time, the sides will be proportional. So it won't be a side equal to a side, it'll be a side proportional to a side. All the sides will reduce down to the same ratio. And then you can also do side angle side similarity, where you have 2 sides and an included angle in the middle of them. The angles have to be congruent, but the sides in similarity will be proportional. The sides won't be congruent like in congruency. They'll be proportional, meaning they'll reduce down to the same ratio. Alright, now I say we're proving similarity because you can't just look at the triangles and say they're similar. You have to actually prove that. If you have to gather more information, you have to. Or if you have to check the triangles for proportionality, you have to do that. You can't just assume. Some of y'all are just going to try to do that even after I teach you this today, and you're going to start getting your stuff wrong. Whenever we ask you to prove 2 triangles similar, you need to check. Especially if it's side, 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 or side, angle, side. You need to write the proportions out and check and make sure the proportions are the same. Alright, zooming in on the first one. So we're doing angle similarity first. It says the 2 corresponding angles are congruent, then the triangles are similar. Now it says determine if the examples below are similar by angle. If yes, write the similarity statement. Alright. Number 1. They gave me 2 triangles right here, and they want me to prove if they're similar or not. Billy, what would you do on this one to prove each? Where you get 47 from? Hold on. What? And 75 and 31. They equal up to 180. That's how you want to. But you're using an angle in another triangle. How you use this angle with these two? I guess so. I see your process. I wish you would have went about it differently. What I wanted you to tell me is find the missing angle in this triangle, and if it matches the angle over here that you have, then yeah, these triangles will be similar. So you could have just did 180 minus 75 minus 74. My bad. I didn't know I wasn't showing y'all that. To find angle C. And then I'm assuming you got 31. 31. So then I know this angle will be 31 degrees. If that's the case, then yeah, these two triangles are similar. Well, that's why they call this angle similarity, because I don't even need to know at this point. If I got all three of these angles is this in here, and I got two angles that match over here, this has to be angle similarity. I know this has to be 74 degrees. So it says determine if the triangles are similar, yes, and then they want us to write a statement. All right, Billy, write a similarity statement. Triangle. Alright, BAC is similar to triangle EDF. Now, she went about that the hard way. I would have said ABC and DEF, but I like that she was able to match up even though she went a different way. The second one. Devin, are these two triangles similar? By angle. If you're going to say yes, you're going to have to explain to me how, of course. Because for me, all I see is angle V and angle Y that are congruent. Say it again. I don't even see no corresponding angles. Where? That's what you call corresponding? You might be on the right track. I feel like he's just using the wrong terms. Emma, help him out. Well, you ain't doing no better than him. Somebody help the man out. Thank you. The vertical angles are congruent. If that's the case, even without numbers here, I can still prove angle similarity, which I'm trying to prove. If these two angles and these two angles are the same, that means Z and W have to be the same as well because of the triangle angle sum theorem. So this is angle similarity. This is a yes. Then from there, well, since you answered it, Kahar, give me a statement. Similarity. V. Uh-oh, I wrote it wrong. You said V. That's a V, y'all. WX is similar to what now? Yeah, YZX. Got the triangle sign. Cool, moving on. Speed up. Side similarity. If all corresponding sides are proportional, then the triangles are similar. Determine if the examples below are similar by SSS similarity. If yes, write a similarity statement. So we're doing SSS on 3 and 4 here. Should be pretty easy to do. All you're doing is matching up on similar sides and seeing if they reduce down to give you the same thing. So I'll do it on the bottom. I'll write my statement on top. So, these two triangles are turned the same way, it looks like, but if they weren't, even if they didn't give you a statement, you can still match up similar sides, because you can go smaller side on both, match those up, middle side on both, match those up, and the larger side on both, match those up, even if the triangles are turned differently. So on this one, I know 3 goes with 6, then I go 4 goes with 8, and then I know 5 goes with 10. I said there and match my similar sides up. If we reduce that, what are we gonna get? 3 over 6 reduces down to what? And 4 over 8, and 5 over 10. Yeah, somebody keeps saying 0.5. That's fine too. I'll be honest with you. This one's easy enough where you can reduce it as a fraction. But if you're just checking for similarity, if you have trouble reducing fractions, you can always do what some kids do. They just divide each of them. 3 divided by 6, 4 divided by 8, 5 divided by 10. They all gonna give you the same decimal too, 0.5 or whatnot. So you could go that route about it too. And on some of the harder problems, you probably just want to go that route instead of trying to waste your time trying to figure out how to reduce each one. And like I said, because sometimes the numbers get big, and you'll see when we get further along, it's easier just to get the decimal and match the decimals up. If the decimals aren't identical, then they're not similar. So these are similar because you got all the same decimals, or you would have had all the same fractions, which is 1/2. Then you just need a similarity statement after that. Give me a similarity statement. I'm not asking you, but go ahead. PQR is similar to STU. Don't worry, I got another one for you. We got plenty of examples. Alright. Number 4, same situation. This is my bigger triangle here. This is my smaller. It doesn't really matter though. Like I said, I always do my stuff left or right, but you can do whatever. If you're just checking for similarity, it don't matter if your bigger numbers are on top or bottom. You're still gonna get the same decimal either way you go. Just make sure you write your proportions correctly. So I'm pulling left or right. I'm doing my smallest number over here, which is 30, over my smallest number over here, which is 24. I'm doing my middle number over here, which is 32, over my middle number on the other one, 25. And then I'm doing 35, largest number, over my largest number, 28. Then I'm checking these. Once again, if you don't know how to simplify, just use your calculator and just get the decimals. 30 divided by 24, 1.25. 32 divided by 25, that's 1.28. I could really stop right there if I wanted to. But divided by 28, 1.25. So most kids have issue with this. I don't know why. I mean, not most kids, some kids. Just a few of y'all. I've said it since the very beginning. For this to be a similarity, all your stuff has to be proportional. If stuff is even off by a little bit, then it's not proportional. Only 2 of these match. These the first one and the last one. So only 2 sides are similar. This third side is not similar right here. If that's the case, there is no similarity here. This is a no. Everything has to be proportional. Side, 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 all 3 have to match. Moving on. Side angle side. If two corresponding sides are proportional and include angles that are congruent, then triangles are similar. Yeah. Determine if the examples below are similar by SAS. If yes, write a similarity statement. So this one, like I said, is pretty much what we just did, except for this is side angle side. Got two sides that are proportional, and then the angles in the middle have to be congruent. So on this one, they're showing me two congruent angles in the middle of my two sides. I just got to check and see if the sides are proportional. So I'm only checking these two sides. I'm matching up small with small, large with large. Once again, 8 over 6, and then 20 over 15. I'm not asking you for ratios on these, so if you like, once again, if you want to just quickly divide and see what your decimal is going to be, you can. This is 1.333 repeating. This is 20 divided by 15. Which equals 1.333 repeating. Get the same run on decimal. So yes, these are similar. Since that's the case, I want a similarity statement. Jorge, let me get one. Say it again. Say KJL. Uh-huh. Thank you. Alright, moving on. Number 6. You checking for side angle side on this one too. It's a triangle inside of a triangle. Jeremiah on number 6. What angle do these two triangles share? Yeah, angle A up here at the top. So that's congruent on both of these. That's why we could look at side angle side similarity right here. They both share this angle right here. We're just looking at side angle side similarity. The sides that I want to match up: 12 over 21, and then 15. I went over kind of far there. 15 over 25. 12 divided by 21, I get this. I'm going to write some of this out. I'm not going to write the whole thing. 0.5714 something. 15 divided by 25. 15 divided by 25, I get 0.6. Jeremiah, are these triangles similar? How?
Because if you are round to the nearest point,
See, that's what I was talking about. You're not going to be the only one to do that. Even after I said it, y'all still trying to do the stuff I told y'all not to. Didn't I just say they have to be exact? Don't try to make them something they're not. Talking about you about to round. You're not going to be the only one today, though. That's going to be interesting. I don't know why y'all try to force stuff to happen. Honestly, y'all don't need me no more. On the back, always similar. think I'm gonna hold off on that third page. The page that says practice. I'm gonna say that for tomorrow. Do that real quick before we do study guide. I'm just make y'all do these 2 pages today. Do the page with are we similar? Those 8 questions right there. It says determine whether the triangle is similar, and then write a similarity statement. So do both. Same thing we just did on the front, but they're all mixed. So it's not going to tell you which similarity you're trying to find. You should figure out which similarity you're trying to find on the back from 1 through 8. You should figure it out by what they're showing you on the triangle. You should figure out if you're trying to find side similarity, side angle side, or whatever. So once you find the similarity, don't just say yes or no. Actually tell me which similarity is. So for number 1, if you figure out that those triangles are similar, this obviously is trying to show you side angle side similarity. So you should put SAS and then write a similarity statement. And then do the same thing for the 6 on the next page too. It says proof of triangles. Not the 6, excuse me. That next whole page you can do front and back. Those other 12 questions. So you got 20 questions I need you to do. There you go. This in class stuff too. This ain't no homework. Y'all should finish this in class. So do the next page and a half. 1 through 8 on that page, and then do 1 through 12 on the page after that. I think I'll look at it for you, Lee.